Okay, Assalamualaikum. So I'm still Dr. Wanu Syahida. Okay, so for the whole chapter 6, I am responsible for video. Okay, so last week we have discussed 6.1.1 goodness of fit for the categorical data. So this is a 6.1.2, still goodness of fit for, but it is for the fitting of the distribution. Okay, so the purpose is we wish to fit a set of data from an unknown population to a particular distribution. Okay, namely binomial, Poisson, and normal using goodness of fit task. Okay, so this is a three common distribution that we use. Okay, for your information, or you can refer to any reference book. Okay, binomial and Poisson, it is a discrete distribution, and normal is a continuous distribution. Okay. Okay. So, and I would like to say that, okay, so for the binomial distribution, you will have two parameter, which is n and p. So n is a number of success and p is a probability of success. And Poisson, we have one parameter, which is a lambda. So lambda represent mean or average, okay. And normal, we have two parameters, which is a mu, it's a mean, and sigma square is a variance. Okay, that one is a basic thing that you have to know about the distribution. Okay, so because of we are using the goodness of fit test, basically it is similar as a 6.1.2 6.1.1. okay, similar because it is about the goodness of fit task. Okay, the difference on a little bit different on the hypothesis and also the critical value. Okay, there are similar. How you calculate for the chi-square similar. Before you calculate for the chi-square, you still need to check the assumptions for the E expected frequency. We have to make sure that the expected frequency at least 5. Okay, so it should be 5 and above. Okay, so similar stuff. The different, it is on the just a little bit different on the hypothesis and also the critical value. Okay, the degree of freedom for the critical value. Okay, so we are still using the chi-square task. Okay, so your hypothesis, this is your step 1. Okay, we still have 5 steps here. So step 1 is to state the hypothesis. So your hypothesis for the fitting of the distribution, it is a fixed already. Okay, doesn't matter what question that you have, this is your hypothesis for the case of fitting of the distribution. Okay, so how we know it's a fitting of the distribution? It is when you have binomial or you have Poisson or you have normal in your question. Then we know it is about fitting of the distribution. If you have the categorical data, there is no binomial, there is no Poisson, there is no normal. Okay, but whenever you have binomial or Poisson or normal, it is a fitting of the distribution. The case of the fitting distribution. Okay, so your hypothesis fits already. This is your hypothesis. Doesn't matter what question that you have. Okay. So HNA, it will be always your data set or population of the set of observed data come from a specific distribution. So specific distribution means that whether you have binomial or whether you have Poisson or whether you have normal. It will be mentioned in your question which distribution that you have. We do not assume by our own. Okay, we do not assume. It will be mentioned in your question what distribution that you have. Let's say that you have Poisson. So your HNA will be the population of the set of observed data follow Poisson distribution. Let's see. Okay, and H1, of course, we know that it will be contradict to your HNA. So the population of a set of observed data does not come from binomial or Poisson or normal distribution. Okay, so H0 coming from that distribution, H1 does not come from that distribution. So this is your hypothesis. Hopefully it is clear. Okay, so step 2 is to calculate the chi-square, but similar step as a as a categorical data. Before we calculate for the chi-square, we need to know what is our E, expected frequency. Okay, O, data given in your question. The observed frequency is a data given in your question. We need to know the E. So formula for the E, it is similar as a categorical data. It is N multiplied with the PI, probability. Okay, but for the fitting of the distribution, probability is given in your question. No need to find as a categorical data. Okay, so probability given in your question. If you have binomial, Poisson or normal, probability based on that distribution given in your question, no need to calculate by your own. So you just use the given probability, multiply with the N to get your E, expected frequency. Okay, I will show in detail when we go to the exercise question later. Okay, but it is similar as a categorical data. But the difference is you already have the probability value. No need to calculate for the probability. It is given in your question. Okay. So you just use the given probability, multiply with the N, sample size, the whole sample size, and then you will get your E, expected frequency. After that, check whether your E greater than 5 or not. If less than 5, then you know what to do lah. We have to combine the category. So similar as a 6.1.1. After you make sure all the E greater than 5, then we calculate for the chi-square here. Okay. So how do we calculate? Similar as what I shown for the 6.1.1. Okay. And then step 3, critical value. So the critical value here quite different from what we have in 6.1.1 in terms of the degree of freedom. Okay, and it is still right task. Okay, so for the whole chapter 6 here, it is about right task lah. Okay, so still right task. So because of that, your probability value will be alpha. It is not alpha divided by 2 because right tail is a one-tail task. Okay, so it just alpha, so degree of freedom K minus M minus 1. So K here, it is a number of category. If you need to combine your category here, so the K here is a new number of the category. If you don't combine any category, then we use the old one. Okay, how many category that you have. The M here, okay, so the M here, number of the parameter of the hypothesized distribution estimate by sample statistic. Okay, so the M here represent number of parameter that we have to find by our own. Okay, for example, Poisson. I said just now, Poisson we have one parameter. Okay, which is lambda. Okay, lambda means represent mean or average. Okay, if there is no lambda in your question, you cannot find anywhere your lambda in your question. It's not given in your question, then M here equal to 1. Okay, it is not given in your question means that you have to calculate for the lambda. Okay, but now no need to calculate for the lambda because before this we calculate for the, we need the lambda to calculate the probability. But since probability is given now, so there is no use for us to calculate for the lambda. But in order to determine the M here, we need to know that lambda is in the question or not, given in the question or not. If there is no lambda given in your question for the Poisson distribution, means that M here equal to 1. Okay. If there is lambda given in your question, means that M here equal to 0. Okay. For the binomial, So binomial, I already said just now, we have two parameters for the binomial, n and p. The n here, it is not the sample size. It is a number of success, so different. Okay, so if n and p given in your question, so m equal to 0. M here equal to 0. If for the binomial distribution, you have only n in your question, there's no p, so m equal to 1. If both are not in question, then m here equal to 0. So similar to the normal, we have two parameters. If both given in your question, m equal to 0. If one of two given in your question, then m here equal to 1. For example, that you have mu only, there is no sigma, then m equal to 1. If both parameters are not given in your question, then m here equal to 0. Okay. I will explain later when we I think I will show to you when we go to the example after this. Okay, so step 4, step 4 as usual, we make our decision based on right data. Okay, and step 5, draw a conclusion. So step 5 here, you just write which statement that you support, whether a statement that mention follow the distribution, your H0, or you support the H1. Okay, you just write here lah. Okay, for the step 5. Okay, this is the example for the Poisson distribution. Okay, so why Poisson? Given in your question. Test the hypothesis that number of defects in the printed circuit board follows a Poisson distribution at 5% significant level. Okay, so we know that it is a Poisson, the number of the defect. So the number of the defect here, it is because of Poisson is a discrete distribution, then it will be the whole number here lah. Okay, the number of the defect in the printed circuit boards is hypothesized to follow a Poisson distribution. A random sample of the 60 printed boards has been collected and the following number of defects is observed. So the data given here is an observed frequency. So we have 4 categories. The category here is a number of defects. First category, there is no defect. Second category, 1 defect. Third category, 2 defect. And fourth category is a 3 defect. Okay, so this is your observed frequency. So thus the hypothesis that the number of defects in the printed circuit boards follow a Poisson distribution at 5 significant level. Okay, based in this question, there is no mean given. We cannot find any average given here. Then means that the lambda here, there is no, means that the value of lambda is not given. Okay, so your m at your critical value here equal to 1 because lambda is not given in your question here. Okay. Okay, the solution here, it is based on, before this we ask you to calculate for the probability. That's why you need to have the lambda. That's why we have to calculate the lambda. But now, okay, but now probability is given in your question, so there is no use for us to calculate for the lambda. You just skip this step. We go to the expected frequency. Okay. So note that since the value of lambda is estimated from the sample, means that we have to calculate from the data given. Okay, so there's no lambda, means that we have to find by our own. That's why the m in your critical value equal to 1. So now there is no, this step is not exist lah. Okay, probability value will be given in your question. You just calculate for the expected to calculate for the chi-square. Okay. Okay. So this example is about binomial. Why binomial? It is mentioned in this question. Okay. So a farmer kept a record of the number of heifer calves born to each of his cows during the first 5 years. The results are summarized below. Okay, so test at 5% level of significance whether this data is adequate for binomial distribution or not with parameter n equal to 5, p equal to 0.5. The n here, it is not the sample size. The n here is a parameter, which is the number of success. So the number of success follow here. The largest success here equal to 5. Okay, so the number of heifer. Okay, what does it mean here? Okay, so the number of cow, it is your observed frequency. Okay, so it is like Poisson, number of defect, but now it's a number of heifer calf. Okay, so first category, there is no heifer. So means that there is 4 cow without the calf born. There is a 19 cow with the 1 heifer. That's what this data meant. Okay, so the largest number of the heifer is a 5. That's why the parameter here, number of success equal to 5. Okay, so P is a probability of success. So both parameters given for the binomial distribution, then the M in your critical value equal to 0. Okay, if 1 given, let's say that there is no n given here, so M equal to 1. Okay, let's say that both are not given. Okay, even though parameter are not given, in this case, you no need to worry because probability already given in your question. Okay, so we just need to know whether there's a parameters or not in your question to determine what is our M. That's it. Okay, if there is no parameter here, no need to worry because you don't calculate your own probability. It is given in your question. Before this, yes, you have to worry. If there is no parameters, because we need that parameter to calculate for the probability. But now probability is given, then no need to worry if there is no parameters in your question. But we need to know whether the parameters are given or not because of the M in your critical value to decide what is the value for the M. Okay, so both given M equal to 0 means that there's both parameters given. If 1 given here, either let's say that N is not given but we have P, then M equal to 1. If both are not here, then M here equal to 2. Okay. Okay, so you can you can complete this step. Okay, and for this step, okay, you need to calculate the probability but no need to do this one. Okay, so you already have the expected frequency here, then you do the next step before you calculate the chi-square. Okay, so hash null, okay, you can fill in by your own hash null. So this data is adequate for binomial distribution. Hash 1, this data is not adequate for binomial distribution. Okay, so before step 2 chi-square, but before that we have to know what is our E. So all the E given here, and then we need to check the E, whether less than 5 or not. So in this case, the first E, E1 less than 5. So what to do? Combine the category. Combine with the next category. And then we have another one here, the last category less than 5. So we combine with the category before that. Okay, so after you do that, calculate for the chi-square. Okay, and then you can proceed lah. Okay, and then we have the normal distribution. So we have sugar concentration in the apple juice measured at 20 Celsius were reported in article of the foods testing and analysis for 50 readings in the frequency distribution table below. Okay, because of the normal distribution, it is a continuous distribution. That's why your category will be in terms of interval. Okay, because of it is a continuous distribution, it must be continuous to each other. Okay, that's why the class the category given here, it is in terms of interval. Okay, so the observed frequency, the data given here, it is your observed frequency, At 0.025 level of significance, is there any evidence to support the assumptions that the sugar concentration is normally distributed when mu equal to 1.5 and sigma 0.5? So both parameters given, then m equal to 0. Okay. Okay, the step similar. State the formulate the hash null here. Step 2, calculate for the chi-square. Okay, so this is how we calculate for the normal distribution, but now no need to calculate. You already given the probability already given in the question. So what we give to you is this one. Okay, for the P1 0.1728, P2 0.2313, P3 0.2182, and P4 0.1452. Okay, so use that probability and then multiply with the n, the sample size, to get your E. After that, check whether all the E greater than 5 or not. After that, calculate your chi-square. So step 3, m here equal to 0. So find your statistical table. Make your decision based on right k-test, and conclusion, you just write which hypothesis that you support based on the decision. If you reject H0, means that we support the H1. So you write the statement of H1 here at 0.025. What statement for the H1? Let's say that decision here do not reject H0, means that we do support the H0. Then we write the statement of H0 here. Okay. Okay, for the exercise 6.1.2, I will discuss in the next video. Thank you.